In this next example, we are going to work on identifying the number of real number solutions. So we have this chart to fill in, which will help us answer this question. How can you determine the number and type of roots for a quadratic equation? Type of roots, it could be a real number, it could be a complex number, which would involve I. So that's what we mean when we say type, and then the number, how many roots are there? In order to do that, well, first, do you notice we have 1, 2, 3 quadratic equations? We're going to graph each equation, use the quadratic formula to find the roots, and then talk about what that means. So, lucky us, they are already graphed for us. So here's a visual of what those 3 quadratic equations look like. Now, this next row where it says work, we're going to do the quadratic formula to find the roots. So in our first example, we'll just run through a quick quadratic formula here. I'm going to zoom in so I can fit this in the square. Okay, so quadratic formula, identify your A, B, and C. So the equation is up above. Our A is equal to 2, B is a -7, and C is a +3. So let's plug this into the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So a -7 is +7 plus or minus the square root of. Grab your calculator, use all of those parentheses when you type it in, and you are going to get 25 all over 4. Square root of 25, that's a perfect square. So that's 7 plus or minus 5 divided by 4. And our two solutions will be 7 plus 5 divided by 4 and 7 minus 5 divided by 4. We can continue simplifying because 7 and 5 are like terms. We took the square root of the 25. Typically, when we leave answers like this, it's because there's still a square root in that term. So 7 plus 5 is 12 divided by 4 gives us one solution of 3. And then the other one, 7 minus 5 is 2 divided by 4 is 1/2. If you look at the graph, you can see that we are crossing the x-axis at a +3 right here and a +1/2. So that's what we just found, where we're crossing the x-axis. Those are also the roots of the equation, of the function. All right, so they do want us to do the quadratic formula 2 more times. I'm going to pause, fill in the work. You can copy it down. I don't think we need to run through the explanation again because we've seen that a few times already. And then we can move on to the next row. All right, so there's the quadratic formula for our second function. What I do want to point out, when we did our b squared minus 4ac, we got a 0 underneath the radical. Square root of 0 is 0. This work right here isn't necessary, but I want to show you where we're getting our final answer. Because these are like terms, we can go ahead and say -12 plus 0 divided by 8, and -12 minus 0 divided by 8. Well, -12 plus 0 is -12, and over here, -12 minus 0 is -12 divided by 8. So we're finding that we are getting just one solution for x. If you look at the graph, that makes sense because our parabola is hitting the x-axis just in one spot at that -3/2. And when I just said that out loud, I caught a mistake that I made. I need to pay better attention. -12 over 8 does not reduce to a -4/3. I think I had 4 in my head because we can divide both of those by 4. -12 divided by 4 is -3. 8 divided by 4 is 2. So our x-intercept is -3/2, and we have just one of them. All right, quadratic formula one more time. All right, so here's our quadratic formula for this last example. When we simplified our b squared minus 4ac, we got a negative number underneath the square root. So anytime that you are square rooting negative numbers, we bring an I, so we can square root the positive number. Square root of 28 will reduce with the square root of 4 times square root of 7. So that's where this 2I root 7 came from. And then I looked at my triangle of numbers. Can negative 2, 2, and 2 all be divided by the same thing? They can be divided by 2. So negative 2 divided by 2 is negative 1. 2I divided by 2 is I, and then 2 divided by 2 in the denominator is just 1, so I didn't bother to write over 1. So we got negative I plus or minus I root 7, and then it just wrote out the two answers. So negative 1 plus I root 7, negative 1 minus I root 7. Now, if you notice, this solution has an I in it, which makes it a complex number because it has real parts and imaginary parts. If you look at the graph, there are no x-intercepts. So if you're not crossing the x-axis, you can't find those real number solutions, and I will show up in your work in solving for x. Okay, so let's keep filling in. The roots is what we just found solving for x. So if we go ahead and fill in, the roots of our first column are 3, that's a 3, and 1/2. The roots of our second equation are negative 3/2, and the roots of the last one are negative 1 plus I root 7 and negative 1 minus I root 7. The value of the radicand and type of roots. So radicand, I mentioned in an earlier video, that's the number under the square root. So in our first example, the number underneath the square root was the radicand was equal to 25. And we had plus or minus square root of 25. That will give 2 real number roots. Roots are solutions. So because we're able to take the square root of 25 and we add that 5 and subtract that 5, that's where we're getting 2. And then real number, because I didn't show up at all, we get 2 roots. How many x-intercepts are on that graph? 2. So our next one, the number underneath the radicand was 0. So if you're plus or minus the square root of 0, square root of 0 is just 0. So if you add 0 or subtract 0, it just gives 1 real number root. How many x-intercepts is that? Just 1. And then last, our radicand on this last one was that negative 28. So plus or minus square root of negative 28, you have to bring in I. So that gives 2 complex roots. And that's because of the square root of the negative number, we would bring an I right there, making that a complex root. How many x-intercepts would that equation have, or that quadratic equation? None. So I know this video is getting long. We can wrap this up. The discriminant, that is what we call that number underneath the radicand. The discriminant is b squared minus 4ac. That comes right out of the quadratic formula. If your discriminant is greater than 0, that means you are going to have 2 real number roots, which on a graph is 2 x-intercepts. if your discriminant, b squared minus 4ac, is equal to 0, you're going to have one real number root, which is one x-intercept on a graph. And last, if your b squared minus 4ac is less than, that shouldn't say d, that should say 0. Let's fix that. So if your discriminant is less than 0, if you get a negative number underneath the square root, you are going to have you're going to have no real number roots, which is why there are no x-intercepts. And what you do have are two complex roots because I is going to show up on that one.